Hello, grade 12s. Welcome to Nova. Welcome to TEM 2. Welcome to Physical Sciences. So, we're going to have a lot of fun, okay? So, we're starting with a new topic called the work, energy, and power, right? It's an amazing topic. And trust me, a lot of people just have a problem with this topic. I'm like, bro, what is wrong with you? You don't understand work, energy, and power? It is really practical, it is really simple, and all of you guys are going to understand it. And as you can see, this topic is divided into three parts, right? So we have got the work, and we've got the energy, and we have got the power. So I'm not going to teach everything at once. I would just try to demonstrate one thing at a time, isn't it? So, where do we start, ladies and gentlemen? We are starting with work, right? We are starting with work. So, I'm just going to write it here. I'm just going to write work. We are starting with work. Now, we do have a brief definition of work, isn't it? And we have learned this definition, I don't know, maybe when we're still in primary school, they would say work is the ability to do work or something like that. I don't know. Work is I don't know. I don't remember. But we do have a brief, definition of work. But what are we looking at, in this topic? Now, guys, before I go any further, I just want to say this to you. Nova is not going to survive if we don't have a lot of people using this platform. And I am not talking with you as Marvel, the person who teaches you math. At this moment, I'm talking with you as Marvel, the CEO and the co-founder of the entire platform Nova. I am speaking on behalf of all the Nova staff members. It could be from our head of software engineers, who is Malungelo, one of the most important people being Luna, and other people. I am speaking on their behalf that, guys, we need you to help us grow this platform to reach as many people as possible. If we don't have a lot of people inside this platform, I am telling you, we won't have enough money to sustain this product so that we keep on delivering this service to you guys. I want you guys to go and tell your classmate about Nova. Just do that for me. I'm begging you. Just tell your classmate about Nova, make them download the app, and show them how the app works. If we have a lot of people using this platform, Nova is going to survive. If not, I don't think we're going to be around for any longer. But with that being said, guys, let's just come back to work, right? Let's just come back to work. Now, I want to introduce you to a very wonderful, formula that you are going to use for work. And it says that work equals to force, and you have got your change in x, and you have got your cos of theta. Now, the question is, what is force? I mean, we have different types of forces, isn't it? We've got the force applied, we've got the frictional force, we've got the tension force. We have got different forces. So this force actually represented those types of forces. And we all know that this force is actually measured in newtons. Now, what about this one, the change in x? Now, the change in x means our displacement, or I'm just going to say it means our distance. And we know that this distance is actually measured in meters. Now, what about this one? What about this cos of theta? Now, the cos of theta actually means our direction. I want you to know it. So the cos of theta identifies our direction. So I'm just going to speak about direction, as this video actually progresses. So let me actually introduce you to what we are talking about, ladies and gentlemen. Now, let's say we have this object, right? So I'm just going to draw this incredible object right here. So let me draw this object, right? So I'm drawing this object. So let's say this object has, a force like this. So let's say this object has a force applied, right? So this force applied, it is 10 newtons, right? And then we also have got the frictional force. So let's say we've got the frictional force, let's say of 3 newtons. So let's say this object, it's actually 3 kg. So I'm just going to say this is 3 kg and it is definitely moving into that direction, right? So how do we calculate the work done by the force applied? So how do we calculate the work done by the force applied? So this is the force applied, isn't it? So I'm just going to say, okay, the work done by the force applied, I have to indicate that I want to calculate the work done by the force applied. So it's going to be force applied, change in x, the cos of theta. Now, let's just add the following information. Let's say that this object, it's actually going to travel from point A to point number B, and it is going to travel a distance of 8 meters, right? So let's say it is going to travel a distance of 8 meters. So what are we actually having? So you realize that what is your force applied? You realize that your force applied, it is actually 10 newtons, isn't it? So your force applied, ladies and gentlemen, it is actually going to be 10 newtons. So I'm just going to write 10 here. I'm just going to write 10. Okay, by the way, I am using my WhatsApp. I don't want to lie. I'm thinking of texting someone. So I'm like, okay, let me just try to, text this person so that they don't think that I'm ghosting them, isn't it? So our force applied, it's actually 10 newtons. Now, what about our displacement? So the displacement, it is actually the distance that is actually covered by this block. So as you can see, to move from point A up to point number B, we are saying that it is 8 meters. So it means that for changing x here, we are just going to multiply by 8. Now let's actually go to this interesting thing that you have never seen before, hopefully. So we want to look at the cos of theta. Now, what did I say the cos of theta is? The cos of theta determines our direction. So the cos of theta just determines our direction. So the direction means that is it going to be positive or it's going to be a negative, right? So let me just show you something. If you draw a Cartesian plane just like this, right? If you draw a Cartesian plane just like this, you realize that if I am to draw my angles, this is going to be 0 degrees, this is going to be 90 degrees, this is going to be 180 degrees, this is going to be 270 degrees, and this is going to be 360 degrees. Now, if I am to do something incredible, let me show you something. If I take this Cartesian plane, right, and I put it here, I'm putting this Cartesian plane, where there is my box. So let me just put it somewhere here so you could understand. I don't know, somewhere here. I don't want it to be messy. Let me just put it somewhere here so you could understand. Now, let's look at force applied. You realize that, okay, my force applied is on the side where there is 0 degrees and 360 degrees. Do you see it? So your force applied, it is on the side where you have your 0 degrees and your 360 degrees. So it means that this is going to be the cos of 0 degrees. Some other people might say it is the cos of 360 degrees. Whether you use the cos of 0 degrees or whether you use the cos of 360 degrees, it is the same, right? You get the same answer. Nothing is ever going to change. So now you're going to use your calculator, isn't it, to calculate your work done by the force applied. So to calculate your work done by the force applied, I'm now using my calculator, by the way. It's going to be 10 multiplied by 8, the cos of 0 degrees, and I get 80, right? So what is the SI unit of the work, right? So what is the SI unit of work? The SI unit of work is actually joules, right? Like as I call it, joule. I just call it joule, right? So the SI unit, of of work, it's actually joules, or it's joule as I call it, right? Now let's actually do another part here. So what I want us to do is to calculate the work done by the frictional force. Now I want to show you something. This is really incredible. I want to show you how to calculate the work done by the frictional force. So how do you do it? Just gonna say, okay, now I want to calculate the work done by the frictional force. So it's going to be frictional force, the change in x, and then you're just gonna say the cos of theta. Do you get it? So it's actually the cos of theta. Now what you want to do is, what is your value of frictional force? So your value of frictional force, as you can see, it is actually 3 newtons, right? So this is genuinely going to be 3 newtons multiplied by, what is your displacement? Now your displacement did not change. It is still 8 meters. So I'm just going to multiply this one by 8, and then I'm just gonna say the cos. Now this is what I want to show you. Which angle or degree rather, it's actually associated with cos, with frictional force. You realize that the frictional force is associated with the 180 degrees. Do you see it? So the frictional force is associated with the 180 degrees. So it means when you come here, it's going to be the cos of 180 degrees. A mistake that you do not want to make is do not write the -3 here. I know that from Newton's laws of motion, you realize that we should have said this is -3. So don't do it. Don't do it, right? Don't do that here. So just gonna say the work done by the frictional force. So now I'm using my calculator. So if I use my calculator, it's going to be 3 multiplied by 8, the cos of 180 degrees. And the answer that I get is -24 joule, right? Not joule. Joule, right? Now it is -24 joule. Oh, by the way, I was teaching someone here. Yeah, I was teaching someone. Okay. Now that you have seen how we calculate the work done by force applied and the work done by frictional force on an object. Now let's say we want to calculate something interesting, right? So let's say we want to calculate the work net, right? Let's say we want to calculate the work net. So I'm just going to recopy all of this stuff, right? So let me just come here and draw it again here. So this time we want to calculate something called the work net, right? So what is the work net? So the force applied, it was 10 newtons, and then I believe that the frictional force was 3 newtons. This entire thing was what? Was 3 kg. And to move from point A to point B, it was 8 meters. So now, how do you calculate, how do you calculate your work net? Now, this is your work net. Your work net is W net. Your work net. Now, before we go any further, what is your work net? Your work net means that you add all the work done within that certain object. So for example, how many forces are acting on this object? You realize that we have got the force applied and the frictional force. So to calculate the work net, you're just going to say the work done by the force applied, and you add it with the work done by the frictional force. Do you see it? That's easy as that. And then you're going to say, what is your work done by the force applied? So your work done by the force applied, we've already calculated it, right? It is going to be 80 joule. And then what is your work done by the frictional force? So the work done by the frictional force, it is -24 joule, right? So what is your work net? So you're just going to say 80 minus 24 is actually just going to be 56 joule. Now, in this basic example, this looks easy. Like anyone could do this, you understand it. But as you go along and do very complicated exam problems, you realize that there's another method that you should use in order for you to find work net. Now, what are you going to do to find work net? You need to use Newton laws of motion, right? So now this is where you have to understand your Newton laws of motion. Now, before we get onto that, guys, I want to remind you that this video is sponsored by the Nova Learning Hub, which is the premium side of Nova. You should help us raise enough funds, and you should help yourself to go and learn within the premium side of Nova, where you're going to have access to all the pre-recorded lessons of all the topics that you are actually looking for. It is so precise, it is so affordable, and it is so helpful. So the way you join the Nova Learning Hubs is you're just going to open your web browser. So I'm just going to go to Safari, and you're going to go to your search engine. I want you to search studentport.co.za, and you're just going to press go. You're just going to land to our amazing website. So you need to go to Join Learning Hubs. So once you're on Join Learning Hubs, you're going to select your grade, and you are going to see our special bundles or our special packages. If you're in grade 10, for example, you're just going to go to grade 10. So obviously this is a grade 12 video. I'm just going to stick with the grade 12 stuff. Just support us as Nova, and also do it for yourself. It's going to help you a lot, and you are going to improve as you should. Now guys, let's actually go back to what we were talking about, right? We want to find the work net using Newton's laws of motion. Now, what is the work net? If you go back to Newton's laws of motion, you remember that there's something called the F net, right? The F net. So at this point, we're just going to say, what is our F net? Our F net, we know that it actually equals to MA. But I don't want us to focus on that. I want us to focus on F net as being your force applied, and then you're just going to minus your frictional force, isn't it? So you're just going to say, okay, my F net equals to, what is my force applied? So my force applied, it's actually 10. And then what is my frictional force? Your frictional force is actually going to be minus 3. This is Newton's laws of motion. We know that the frictional force is going to be a negative. So your F net is actually going to be 10 minus 3, which is just going to give us 7 newtons. Now, what do we want to do? We want to calculate the work net, isn't it? So what we do is we're just going to say, okay, we need to calculate the work net. And this is simply just going to equal to the F net, change in X, and then you say the cos of theta. Now, what are we going to do? What is our F net? Our F net is actually 7, isn't it? So it's just going to be 7 multiplied by, what is our distance? So our distance, as you can see, it's 8 meters. So we're just going to multiply this thing by 8. And then we're just going to say this is cos. Now, let me tell you something. Let me whisper this into your ears that you never forget. Each and every single time we look at the cos theta of F net, so the cos theta of F net each and every single time, use 0 degrees. I'm just going to repeat this that you do not forget. Whenever you use Newton's laws method, if you use F net, your cos of theta should always be 0 degrees. So you're not just going to say, what is 7 multiplied by 8? You find that your 7 multiplied by 8 is simply 56 joule. And this answer and this answer are basically the same. Now, I want you guys to realize something. You realize that if you use the traditional way to find the F net, it means that you need to first calculate this and then calculate this and then come here. It is a little bit too long. But if you use your Newton method, you just use your Newton method and then you just do this, it looks a little bit easier. Now, this is the introduction, guys, to the Newton, now I'm saying Newton, but rather it is the introduction to work, energy, and power, and we are still focusing on work. I'm hoping that you guys are going to invite your friends and you are going to engage with our platform so that you can learn a lot of stuff. With that being said, guys, I am going to see you on the next video.